We stopped last time with this discussion on this slide. We discussed with you planes and the way we look at planes in Rn. Of course, the way we look at planes in Rn, it's modeled from the way we look from our experience with planes in 3D, in R3. And I gave you some remarks also. Two ways we look at plane normally. One of them is via this vector equation like this. Yeah. And effectively, this is the plane which passes through the tip of the position vector A and parallel to the vector B and C. That's the one which is on this diagram. The other way you might probably find useful to look at planes is when you have three vectors like this, and you ask the question, what would be the vector equation or parametric equation? Vector equation, it's the same as parametric equation. What would be the parametric equation for the plane which passes through the tips of these three vectors, through their points for which these are position vectors? And the answer to that would be, the immediate answer to that will be something like this. That's where we stopped. We discussed with you what kind of what will happen if you restrict your lambda and mu parameters to different subsets. What kind of elements or subsets of your plane you will come up with? For instance, we discovered with you if I vanish mu in this vector equation, so mu will be gone from here, and this whole term will be gone. The remaining bit will be the equation of the line, and that would be the line A0, A1. I'm not sure if I showed you that line last time. I think it's very easy to draw. I'm not sure if I traced that line for you last time. A0, probably I did. We'll just trace it again. I just trace it again. If I trace that line, that's a tracing. Now I remember. Yes, I did that. If you vanish lambda, for instance, you will get the line A0, A2. That's the one which was on the picture before I change it. It is more trickier to see why, for instance, if you take this kind of condition, you will end up with the line A2 to A1, and that happens because when you take this condition, this bracket will vanish, the whole presence of A0. And these two, although they seem to have two different parameters, you can always replace one in terms of the other, because you can solve here for mu, for instance, and you will end up with the equation of this line. And I think I have a tracing for that line too. That's the tracing for that line. All right. Just if you I have a few more remarks in relation to this particular representation of a plane, and one of them says this. What do you think will be on the plane if we still like think about what will happen if I don't let because when you look at this equation of the plane, your lambda and your mu, it's like free parameters. You're free to take any pair of numbers for them to substitute into this equation. And when you put some extra restrictions on those couple of parameters, you will come up with some subsets. Like I said, this restriction reflects into a line, this one reflects into the other line, this one reflects into the third line. If you couple this restriction with this extra condition on lambda, this will get into not a line, but into a segment. So just a piece of a line between 2 points, A0 and A1. Now, what I want to ask you now, what will happen if I consider this kind of restrictions? Look at this. Lambda and mu bigger than 0, and lambda plus mu is less than 1. So effectively, three inequalities here. Last time one of you came to me after the lecture, and I realized this kind of writing, which I use very often, may cause some confusion. When I write like this with comma, it depends on the context, but here it means that both. So this inequality applies to both of the numbers, to lambda and to mu, independently. Anyway, so if I have these three inequalities, effectively, what do you think this will be? What kind of subset of my plane will correspond to these three inequalities? What your intuition tells you now? I mean, you can rely on your 3D intuition, of course. Your 3D intuition should be enough. Three-dimensional one. Well, we can just do it step by step if you don't see it right away. For instance, what happens if let me just split this actually. I said two inequalities here, let me split this, let me just split this. It will be easy if I split it. Let me just remove this. You know, say lambda bigger than 0, comma mu bigger than 0. 0. So now it's all expanded. So free inequalities. You can reason the way you reason with many other inequalities. You had a few problems actually in this topic already when you have to picture the inequalities on the plane. Actually, you can do the same thing here. What will happen, for instance, if I replace this line with the equal sign? Lambda equals 0. We just discussed this with you, right? That will be this line. What happens if I replace here 0? Mu equals 0. That will be this line. And what will happen if I replace here 0? Lambda, sorry, I replace it with the equal sign, but not 0, of course, 1. What will happen if I take lambda plus mu equal 1? It will be this line. So if you replace any of these inequalities with the strict equalities, you will come up with lines. So the inequalities, now how do you do this passage from equalities to the inequalities? You say it will be one of the areas of the plane in which my free lines split the plane. How many areas, by the way, we will have? In how many areas my lines split the plane? There was actually a question in the yellow book in relation to math induction. I did this question in tutorial, that's why I remember it. There was a question in the tutorial in relation to how many areas on the plane you will have if you throw n lines on the plane. If you didn't do that question, you probably should do it. It's an interesting question. But this time we throw how many? So one interior here. All right, I'll trust you, 7. We did this question. I remember I did this question with the math induction, but it doesn't matter. Now, of course, out of this 7, which you found for me, you have to choose which exactly correspond to the inequalities here. At this stage, probably I just tell you that for this set of inequalities, when you go lambda bigger than 0, mu bigger than 0, lambda plus mu less than 1, it will be the interior of this triangle, A0, A1, A2. If you go, for instance, if you flip this inequality to the opposite one, lambda less than 1, you will cross the line which correspond to lambda. So you will cross the line A0, A2. So it will be this area in this section of your plane. If you flip this inequality, because equality corresponds to this line, you will cross from the interior to this direction. So it will be this area of the plane. I hope you imagine what kind of domain we're talking about. You have plane, you can look at it from the top of this plane. You threw 3 lines on this, 1, 2, 3, and on these 3 lines, they split the plane into 7 subdomains. And different choice of these inequalities will correspond to different subdomains. This particular choice, which is you see right now on the screen, that's the interior of this triangle. That's what's said here. Triangle A0, A1, A2 with interior, not just a boundary. Good. Now, in the same line of reasoning, in the same line of thought, you can tell me, probably, you can tell me what will happen if I put this kind of restrictions on my lambda and mu parameters. Look at this. Lambda and mu between 0 and 1. Again, that's a sort of writing which I used last time, which caused the confusion here. When I wrote this, I meant that both of these numbers they between 0 and 1. So expanded version of it will be 0 less lambda less 1 and 0 less mu less, what the hell? Where's my less sign? And 1. I know. It's like it's not like when you see something like this, it doesn't necessarily mean that it's always interpreted like that. But you have to, of course, look at the context. But here, that's what I mean by that. And last time on those slides, which I haven't put on YouTube yet, but when I will, if you had any confusion interpreting this writing last time, that's exactly what was meant there. All right, so. Here's again, the question is, what do you think will be if I restrict my lambda and mu parameters like so? What do you think, what kind of domain or subset of the plane will emerge under such conditions? Again, I encourage you to think with the equal sign term. So what will happen, for instance, if I go for the equal sign here? We know very well what will happen, right? Lambda equal naught, that's this case, and not A2 line. Similarly, if I go with the equal sign here, mu equal naught, it's this line. So at least these 2 lines, A0, A2, and A0, A1 will be involved in the subdivision of my plane. Now, what about the equal sign here? Lambda equal 1. What kind of, it will be a line again. What do you think will happen here? I'm not going to do it. I'm going to write this but I ask you to do it in your heads. Look at this inequality. Look at this vector equation of your plane. What will happen if you plug in lambda equal 1 in this plane? Well, this one will cancel this one, so you'll have negative mu in here. This will be just a1, and here we'll have mu, right? Probably I'll write this for you. So you will have the vector equation like this: x equal negative mu vc a naught, plus a1, lambda went into 1, just 1, right? And the final one will be plus mu vc, or right, v2, like this. That's how it will look like if I put lambda equal lambda equal 1 into my equation like this. If you just combine these two mu's together, you will have, it will be x equal a1 plus mu times a2 take a naught, right? That's how it will look like then. Everybody agrees with that? Simple arithmetic, simple vector arithmetic. Now, when you look at the parametric equation like this, you will tell me this equation represents line. Now let's just try. Let us try to identify this. Let us identify this line. It is the line which goes through the tip of the A1 vector. So it goes through the capital A1 point, through this point. Now it will go parallel to the A2 take A naught. So it will go parallel to this line, right? So it will be the line here. That's the kind of set you will come up if you take lambda equal 1. Similarly, if you take mu equal 1, if you do the same kind of arithmetic now with your vector equation of the plane, I'm not going to do it now because you have the example, you can try to follow my steps. You will come up with the line which goes through the tip of the A2 vector, yes, A2 or A2 point A2, parallel to this line, and you will come up with this line, this kind of line. So altogether you will have 4 lines now, because four equations give you 4 lines, A naught A1, A naught A2, and those parallel here and parallel here. I think I have a diagram for that. Oh, that's the one. That's where they intersect. If I call this point A3, my lines, these 4 lines, they will be arranged as if they are a parallelogram, and they split my plane into some subdomains. The actual choice of these inequalities will be the interior of this parallelogram, and that's what is said here. These 2 inequalities represent the parallelogram A0, A1, A3, A2. Again, if you start playing with this, if you start reversing one of these inequalities, you will start crossing the lines in some direction. If you reverse this inequality, lambda equal naught, you will cross this line, this side of your parallelogram, and you will go the other way. If you, for instance, yeah, I know. Well, actually, it's a bit trickier than that. I'll let you think about that. What will happen when you start reversing the inequalities? No, well, it's not that much difficult. It's just when you reverse, for instance, this inequality, when you say lambda less than 0, then this inequality by itself already just sort of has this one in it, right? Because when lambda less than 0, lambda is already less than 1. So this inequality becomes redundant, and so you will have 3 inequalities, and the whole area will be sort of stripped half infinite in one direction. There is some room for the research here, for the play. There are some questions of similar nature in Yellow Book. You will have a chance to practice with this. Any questions?